We talked a lot about binary numbers, 16-bit numbers, 8-bit numbers, but now we're going to talk about binary data. The keyboard on your computer is modeled after a typewriter, has many of the same keys. I remember the old typewriters used to have a cent sign. They had a dollar sign, so why not have a cent sign? Most of these characters traveled over from the typewriter keyboard to the Ascii keyboard. ASCII is pronounced ASCII, as the footer says, American Standard Code for Information Interchange. There were many codes that were tried before this, kind of a form of extended binary coded decimal and many things, but it was ASCII that finally set the standard and took over. And even by today's International Character Standard, with Chinese characters and French and Italian, many different languages have characters that are just not represented in the ASCII table, because after all, ASCII was designed in America for English. So you can Google ASCII table, ASCII chart, and you'll find a flood of information that'll show you the values between 0 and 127 and what character they represent. I'm going to show you where ASCII is used in a piece of code. In fact, every slide that you've seen was designed with ASCII characters, because I have a United States ASCII keyboard. If I had a keyboard from another country or a different language, it would not be using ASCII. But we're going to focus on ASCII because it's extremely popular. There's a couple key values, pun intended, that you should remember, and this will help you understand and decode ASCII in your head pretty easy. First of all, the space is 20 hex. It's the first printable character. The first 20 characters of the ASCII table are not printable. They're things like carriage return, line feed, bell, and a lot of control characters that just back in the day seemed to make more sense than they do today. But just know that the first printable character starts at 20 hex. The numbers 0 through 9, the top row on your keyboard, or the numeric keypad, have ASCII values of 30 through 39 that map exactly through 0 to 9. So by taking off the upper 4 bits of the 30, you can convert the ASCII value to a numeric value very simply by removing the upper nibble. The capital A starts at 41 hex and goes in alphabetical order from A through Z, followed by special symbols in between. And then the lowercase a is 20 hex away from it, higher. So 41 and 61 are capital A and lowercase a. 42 and 62 are capital B and lowercase b. Just know that the characters are 20 hex or 32 away from each other. Look at an ASCII chart for details. And if you remember these 5 key points, which really I kind of think of it as 3, just got to know space is 20, 0 starts at 30. You'll know that 9 automatically, if you know 0 starts at 30, 9 ends at 39. And if you know the A's and the uppercase A and the lowercase a are 41 and 61, that's it. Now let's look at some C code. I typed in a program. The source code is shown in red. Hello.cpp. This is your typical hello world. So notice I have hello, space, world, period. That's my string that's going into printf. All the code is typed in ASCII, but more importantly what I want to show you is that that string hello world is also in ASCII. I run the C compiler to create an assembly language output. So hello.cpp gets converted to hello.s, and then I assemble the code hello.s into hello.lst listing file. When I look at the listing file, I will see on line 5 a directive.ascii where it says hello, space, world, period, and then a \0, which is a null character. We can look at this in more detail. So we got the ASCII hello world with the null, with the red frame around it. And then we have the hex characters that are at address 0 through address C, which are shown in line 8 through 11 in the text editor of the listing file. So H is the 48, right? We know it's in the 40 range. It's not the 60 range. 40 and 50 have to be an uppercase letter. So 48 is an H. 65 is a lowercase e. 6 Charlie is LL. And on the next line, line 9, we see the 6F for the O of hello, followed by 20 hex is a space. 57 is the capital W. 6F is the O, same as hello, after the W in world. Then we have R on line 10, 72. And then 6 Charlie, which is the L. 64, which is a D. 2E, which is a period. And 00, which is our null character. So when this prints out, there's a pointer that reads these bytes out of memory. 48 is not a null, so we print the 48. It goes to your character generator and draws a capital H. The ASCII characters are kind of twofold. It's the characters that come out of your keyboard. No matter what type of keyboard you have, you will have ASCII. Notice your keyboard has F1, F2, F3. Those are not ASCII characters. Print screen, scroll lock, insert, home, delete, page up, page down are not ASCII characters. The arrows are not ASCII characters. So ASCII is the printable characters that you see coming out of your keyboard. And then the character generator that actually draws the glyphs on the screen uses ASCII to know what the characters actually look like, whether they look like an A or a B or a C. And that's a 7-bit code. There is 8-bit ASCII from the display point of view. There's extended characters that IBM added to it, but that's kind of beyond the scope of this. You can look that up. Those are not as standard as you would think. Sometimes the 80, 81, 82 hex display different things on different computers. ASCII is the standard, which is only 7 bits. I will point out that this is not the key code that goes down the wire or down the Bluetooth from your keyboard to your computer. Those are USB scan codes. Scan codes are totally different. In fact, I'm not going to go into that in detail because that could be a whole series on scan codes. Every key on your keyboard has a scan code, so when you hit the left shift key down, that's a certain scan code. When you release it, that's another scan code. The key was released. When you hit the right shift down, even though it's a shift key and it has the same functionality, they're different scan codes. The 0 on the numeric keypad is different than the 0 on the top row. Every key has a different scan code, just so you know that. Here we're talking about ASCII, which is the bread and butter from the character generator to the keyboard. So that wraps this up on ASCII.